I'm John Wilson. I'm a owner and director of BWB Management. It's a management group that manage a number of farms in northern Tasmania, Juniper Lea being one of those farms.
Hi, it's Luke here. I'm the farm manager at Juniper Lea. Juniper Lea is in its 4th year of milking. We're currently milking 1,000 cows on 260 hectares of irrigation. We have 500 hectares available land. We're doing a next stage of irrigation, will be another 21 hectares. We run crew here, a very light crew of only 4 full-timers. Climate here in Derry Plains, we've got the annual rainfall around 1100. We're sort of wet through from July through to September, and then we have spring in October, November, and then we irrigate from November through till March.
In this environment here, without water, we wouldn't have proceeded with a dairy farm conversion. Water is a critical part, irrigation, to grow our grass. So we actually employed an independent consultant when we're looking at design. The factors for me that are important in design relate to what sort of dry matter of pasture can we grow for per megalitre that we've got. Our water is a critical component. We want to utilise that fully. Then we look at factors, the capital cost of that irrigation infrastructure, and then we look at things like the running cost of that. And fourth factor that's really important is how easy is it for our farm managers to operate these irrigation systems on a day-to-day basis. So in that, we employed an independent consultant. We sat down and drew a lot of circles on maps because our priority was around, firstly, pivot irrigation. So we tried to maximise pivot irrigation because that ticked most of those boxes that we're talking about. From there, we still had surplus water, and then we looked at, okay, what's our next best method of applying water? And that came up with the solid set irrigation. So the solid set irrigation, that fitted into the areas where it wasn't feasible to have pivots. So this was areas that were corners of pivot paddocks, it was areas of funny shapes, it was areas where there were power lines, existing power lines going through that prohibited a pivot to run through that area.
The solid sets is a fairly new sort of concept and design, especially the one we've got here. So it's a bit of learning about that and how we can utilise the water the best we can. So keep a very close eye on the evapotranspiration in the area to do that. The one thing we've noticed with the solid sets compared to the pivot is we have less runoff with the solid set because it puts on a much more uniformity of water over a longer period of time. So we seem to get better penetration into the soil, which we've found has increased the grass growth on them paddocks. Different challenges between the two are the solid set's got all posts in the way for contractors and that, but I'm not a contractor, so it doesn't worry me. Pivots, we have pivot ruts we have to deal with here, and broken fences, so they're always moving. So every year we get a rut buster in and we do maintenance on our pivot ruts continuously, which I think will make the longevity of the pivots much better. The ability with the solid set, it'll put on that 6 mils over a 15-hour period with the sprinklers, so it's got a greater ability to play catch up than what the pivots do. So if we have a breakdown with the motor or anything, we can catch up with the solid sets quite rapidly, and we can go putting 4 mils on every 10 hours and catch up really quick without losing the ability to get the penetration into the ground, which is what we really chase here.
So when we looked at pivots, on those criteria, they do produce good tonnage of dry matter per megalitre applied, get even distribution. They're good to be in terms of control of water application, moderate capital costs, moderate running costs, and to a large degree there's ease of management in running those on the whole. With the solid sets, they had versatility in terms of where we could put them. Also very good uniformity if they're designed properly. Higher capital costs, probably similar running costs if you take into account there's minimal depreciation over time, and very easy to manage from the farm manager's point of view. That was the criteria for going with pivots and solid set. So when we sat down and looked at the design of the pivot, one of the important things is to look at, okay, what is our maximum evapotranspiration rates that we need to cover that, plus we need a bit more for contingency. In other words, very hot conditions and also allowing for breakdowns, that type of thing. So we elected to put a 6mm pack on here, appreciating that our highest evapotranspiration is probably going to be around that 5mm a day. In designing that, we designed it around the pivots running 24 hours to apply that 6mm. And the reason we did that was basically around the capital cost of the pivot. If we wanted to say, let's run these pivots just at night on night rates, we would have had to put in bigger pumps, bigger pipes. There would have been bigger pipes on the pivot to say, give us a 12mm pack. So we elected to lower the capital costs, maybe slightly increase the running costs, but still have that flexibility for catch up if we needed it. In an operation like this, we're talking very high capital inputs. I think the irrigation was something like $1 million spent on this farm. So we want to get it right from the start. So that's right in terms of the hydraulics and that side of it. The other thing is that for all of the pivot designs, we actually used James to provide a design for each pivot and specifications around the quoting. So we're actually able to go to all the various suppliers with the same document that they were to quote on. And that just eliminates any confusion or this is included or not included and that type of thing. And I think that's very important in terms of getting a pricing in terms of like with like. So another consideration we took when looking at pivots versus solid set. Solid set has a higher capital cost per hectare to install, but overall the running costs are very similar to pivots. You run the solid set at a higher pressure, so you've got a higher electricity cost. But when we took into account depreciation and compared that to a depreciating pivot that you may only get 20 years out of, plus the maintenance of wheel ruts and the labour involved, the overall running costs between solid set and pivot were very similar, we believe. What we actually had was more water available, and we were looking into what do we do next with our irrigation. So we went back and looked at what can we actually do to lower that capital cost. So working with James on that, we looked at a variation on solid set where we used big sprinklers but individually controlled, as opposed to what we've currently got where one valve sets off 5 sprinklers. This meant that it was able to lower the cost of the piping. We needed lower volume to each sprinkler. We were very happy with the grass we were growing under our current design, and we said, yes, that'll be our benchmark. We don't want to reduce capital cost and also find that we're growing less grass. What we actually did was that we went out and measured the uniformity of distribution of the irrigated water under our current system. And that came up with a figure of 82%. So we said, okay, 82% is going to be our benchmark. If we do any more development, it has to be around a design that at least reaches that 82%. And we trialled a whole lot of different sprinklers of different prices and different qualities with different throw ranges, and we measured the distribution of those using catch cans, radial catch cans. We're able to utilise computer modelling to actually say, to get 82%, what is the pattern that we need to put the sprinklers at to achieve that. So that meant that some sprinklers we actually needed to use more per hectare, others we could spread out a bit further. We started building that into a costing model of, for this particular sprinkler, we need so many per hectare, that's our cost. It'll still achieve our 82%, which is our baseline. We were happy with that. That was how we made the decision on the actual sprinkler we were to use and the actual design and the spacing of those sprinklers. It is so easy to spread them out that little bit more and save a lot of capital costs initially, but the drop off in that uniformity is quite dramatic. And so, yes, you save some capital costs, but again, if you're not growing that grass per megalitre of water applied, you haven't achieved your objective. So for anyone that's looking at investing in irrigation, I think key points is, one, obviously do your planning well. I think it's quite critical to use an independent consultant in terms of getting good advice. The other side of it is that we've talked a lot about growing more grass, but unless that grass is efficiently utilised, your grazing management is right, you're not actually getting the true benefit from that irrigation. So what we're looking at is we're looking at putting water on to grow grass, to produce milk, to make our money. The other thing that I've found is that it's important to look at what other people have done in terms of their design, things that have worked well, things that haven't worked well.
The things that are important to me is keeping the system very simple and straightforward to use, and we utilise the local discussion groups to gather that data, also to find out what everyone else is doing right and wrong, so we can keep moving forward as well and best utilising the water we have available.